So are you guys 3rd and 4th grade? Okay. So I'm going to start with a little DVD that'll probably be like 5 minutes or so, which is based from a book called Number Talks. And the subtitle of the book is Helping Children Build Mental Math and Computation Strategies. And you'll see in the video that the kids in classes that use Number Talks are really strong in what Bob was talking about, understanding what they're doing. So they're not just doing like, oh yeah, the teacher told me to do this and then multiply this and carry the 1 and do that. They totally know what they're talking about. So we'll watch that first, and then I'll show you some of the structuring stuff that I do with kids. And you guys may or may not want to take this stuff home. It kind of depends on if your kids are, you know, super good at math. They might not need this stuff. If you have younger siblings at home, you might want it just so that they're, you know, playing with it too. Let me get to 3rd grade, 4th grade. Let's do 3rd grade. Let's do this one. Do you want to flip the lights?
So if I had 4 sevens, you're saying it's the same as 2 14s? How does that work?
Because 14 plus 14 equals 28.
Okay.
And you double.
Grant, what do you notice?
It's because the 7 doubled is 14. And then the 2 on the bottom doubled is 4.
Alright, go back to when we did the grocery store poster. Remember when we were looking at those baskets of apples, oranges, and they were kind of in rows? I want you to think in your head, if you can see a crate like we saw in the poster that maybe has 4 rows of apples with 7 each. And I want you to see if you can see that in your mind, and see maybe how you can figure out you could put it in this form instead of in this shape. And see if you can see that, how it would look. You remember the poster I'm talking about, Ryan? Madison, Walker, what would it look like?
Do I have to draw it?
Well, if you can tell me, I'll draw it. If you want to draw it, you can draw it.
I don't want to draw it.
Okay, come draw it.
I want to draw it.
See if this is what you were thinking. Watch Madison and see if you were thinking the same shape as she was. Okay, is this what you pictured in your head?
No, I have a best
Okay.
All right, yes. I think she has to do it the opposite way. There are 4 rows. They each had 7 in each row.
If you took your crate and did this, it would be the same as what Andrew's saying. Would that work for you? Okay, so I guess it doesn't matter either way. So I could have written this.
You can just look at it sideways and
Just tilt your head.
yeah.
Okay, so I could have written this. Or I could have written this. You know what it still looks like? Okay, so, how many apples are in Madison's crate? Okay, we have 4 rows of 7 or 7 rows of 4. And we're down to our last answer. We're pretty sure it's 28. How do you think it would look like this if you took them out of this crate and put them in this shape? Because we said the same thing. 2 7s and 2 7s is 2 14s. So it should be the same.
I would have like 2 rows of 14.
You want to draw it? Alright, Ari, see if you think this is what you're thinking. How many apples are in your crate? Okay, Ryan, how are you picturing it? Like this?
It was kind of like that, but I thought it would be more easier if you drew 2 apples and then 14 down.
Okay, so if we took this crate and we turned it that way, would there still be the same number of apples in it? Would that have been the picture in your head? Okay, so Madison, Mike, did you think 14 and 14? And that's where you came up with your, okay, so we have two 14s, oops, and we're pretty sure that's 28, and we've got 4 7s, and we think that's 28. Now I want to go back to what Grant said. He said, if you just double 2, you get 4, and you double 7, you get 14. These do have something to do with each other. I want you to think back to what Grant said. Madison, what do you think?
It's like these. It's the same thing. These are just in the wrong. It's like a different order. This is 14. That's 14. That's double. That's double. That's double. That's double.
Okay, so how could you make this picture look like yours? What would you do if you could take these apples and move them with your hand? Where would they go?
Like all these will go in like one row, and then all these will go in one row.
Okay. All right. Anybody else have another idea? I kind of see what you're saying. Grant?
If you get it like this, it'd actually be better if you turned it, but you could take this and go that.
All right. Did you hear what he just said? He said you took this and you swung it around, it would look like that. What do you think that has to do with multiplication? All right. Ion.
14 times 2.
How do you think this could help you the next time you see a multiplication problem? Avery, what do you think?
Because if you see like 2 times something, you're actually doubling just the amount.
Okay, I'm going to erase your great pictures and we're going to move on a little bit, but I want you to keep this in your head. I've got some really interesting ideas for you about this that we are definitely going to have to explore later.
Okay, if you don't mind hitting the lights again. Thank you. So, I'm not sure I have enough of these. Let's see. Let's see. Okay, thank you. I don't. I might have, hang on, I might have some more in a folder. Yeah, I'll just talk while I'm looking. So on this sheet, which says first grade number sense on it, it should just say number sense on it because number sense is for every grade level. This is something that if you have a kindergartner or a first grader, you will get one. Yeah, I have some that say kindergarten number sense on them. You will get one later in the year, probably around conference time, and it will say kindergarten number sense or first grade number sense, and it's all the same. They're the same exact sheet. I just have different titles on them. So really, it should just say number sense on it, and it shouldn't have a, who gave me theirs? Did you give me theirs? Okay. Okay. Does everyone have them now? Okay. So number sense is the ability to understand numbers and how they relate. Did you notice in the video, do you think those kids understood numbers, like how they relate? Yeah, I think they did. One of the things we talked about in the session right before this, we did a different problem with them, and theirs was an addition problem, and they were adding 16 and 15, I think it was, and the kids were all pointing out that the 1 in the 16 and 15 was really, what's that 1 really? If you have the number 16, it's really 10. Okay, and the kids in that classroom all, would talk about it, and they'd go, well, I know if you have 16 and 15, there's 2 10s, so that's 20, and then if you take the 5 and the 5 from the 15 and the 16, that would be 30, and then 1 more would make 31. So that's the way they were talking about numbers. And oftentimes when kids look at numbers, they'll look at 16 and they'll say, well, there's the 1, and you'll say, what is that really? And they don't know. They think it's a 1. And really, that 1 is standing for a 10. And that's the whole thing about place value. That's why place value is so important in numbers. So anyway, the important part of this, your kids being 4th graders, counting forward, counting backward, number ID is probably not going to be an issue for them. Structuring still could be, because they may not have done enough of this to where they're structuring where we want them to be. So structuring is basically taking apart numbers, it's called decomposing, and putting numbers together. And you want them to be able to do that to 20, supposedly by the end of second grade. Now, most of our second graders are not structuring to 20 by the end of second grade. But that's the goal. So I am going to give you guys the stuff that we made with the other, the younger grade kids, just for you to take home. Like I said, if you have younger kids, they'll like it. And for your older kids, it'll give you a sense of, can they do this or can't they? So you'll get a couple different things. These are called 5 frames. This is what's on a red sheet of paper. With these, you can just show it to them. They can tell you, you have to establish that it's 5. There's a blank one, so you can establish that there are 5. How many dots do you see? How many are empty? So how many, or the way I word it would be, how many do you see? And they'd say 3. How many more to get to 5? So they'll say 2. Okay, and then you just do, how many do you see? 4. How many more to get to 5? 1. So they know 3 and 2 make 5, 4 and 1 make 5. There'll be one that has all 5, and they'll know that 5 and 0 is 5. Then, when that's too easy, you go on to 10 frames. And it's the same type of thing. So how many do you guys see? 6. And how many more to get to 10? 4. Okay, so for us, that's really easy. For kids, it's not. They have to learn that. And so those are the 5 and 10 frames. Then this is the one that really trips up probably the most kids, because a lot of kids do know, what it takes to get to 10 or what it takes to get to 5. These are called dot cards. Very self-explanatory. And the reason that kids have a hard time with them is because they try to count every single dot. And what we're trying to do we need to go? Maybe 5 minutes? Is that too much? Yeah. Oh, sure. Okay. So what the kids often do when they see these is I'll say, like, what did you see? And they'll say 4. How did you know it was 4? And they'll go, well, I closed my eyes and I took a picture of it in my head, and then I went back and I counted every single dot, which is the exact opposite of how we want them to do it. So what we want them to do is called subitizing. And what it means is looking at a group of dots or objects or whatever and being able to tell how much it is without counting by ones. So they still may need to, they're probably going to like and say 2 and 2 is 4. Okay? So I'm not saying that they're going to be able to look at these huge numbers of dots and just, they're not Rain Man. They're not going to tell you what it is. But they can break it into smaller parts that they understand. Okay? So if they see this one, what are they going to say? 4, but then when I say, how'd you know that, what will they say? Yeah, 3 plus 1 plus 3. Okay, so what you're going to do is you're going to have some red dots and some blue dots and some index cards. And at home, you can just take these home and you can just make. You can do it if you want to make them harder, make it all one color. If you want to give them a little clue, if it's a little bit bigger number, make it 2 colors. So then that kind of gives their eyes something to focus on and say, like, oh yeah, that's 5 and 2 or whatever it is. And then the last thing I'm going to give you is called a 10-bead string. You can start with a 5-bead string and then work them up to a 10-bead string. So 5-bead string, you would just hide some. They'd see 3. How many am I hiding? 2. So the way you tell is whether they're ready for a 10-bead string is with all of these things. If they can do all of it to 5 without having to count, use their fingers, look up there and think, then you know they're ready. It's got to be pretty automatic. Okay, when they're ready, then you put on 5 more beads. Okay, so when you come up, if you'll take one of each color paper, red and white, I've already got that, and then one of each, the red and blue labels. I'm getting some more of these out for you. There's one string for your 5 or 10 beads, and 10 bead string, and then a baggie. So if you just want to start here and go around, let me get these open for you.